So, good morning, folks. Thank you very much for joining today. I'm really excited to talk to you about Kubernetes native Spring apps with Quarkus. So I know this title is a bit of a mouthful, but I'll do my best to explain everything about it. And of course, any questions you have, you either ask me at the end of the session or I'll be around at the conference if I don't explain something great, or if I spark your interest more and you want to learn a lot more things, feel free to ask me. So let's get started. Let's get the boring stuff out of the way. I'm an engineer at Red Hat. I work on the Spring Boot team where we do various things around the Spring ecosystem and some stuff about the developer experience on Kubernetes. And lately I've been doing a lot of work on Quarkus and specifically bringing Spring APIs to Quarkus. Other than that, I'm also a co-organizer at the Athens Kubernetes meetup. Athens, Greece, that is. And I'm also a speaker. Spoke at various conferences and meetups for either Java topics or Kubernetes-related topics. So since we have a fair amount of ground to cover today, I wanted to give you an agenda real quick. I'll do a short introduction on Quarkus. I'm not going to go into much detail because I'm assuming that most of you have heard about Quarkus already. You probably attended Emmanuel's presentation yesterday where you got a lot more details. Then I'm going to talk about how to use Spring APIs on Quarkus, what we have, what Spring APIs we implement on Quarkus. We'll do a demo about that. Then we'll move on to a slightly thornier topic, which is the cloud native deployment and how Quarkus applications are very fit for this new cloud native world. And I'll do a demo showing a Spring application on Quarkus deployed to a cloud, and you'll immediately see the benefits of the very low runtime footprint that the Quarkus applications have. So to get started, what is Quarkus? Quarkus is an open source stack to write Java applications. And the architectural pattern that we usually have in mind when writing, when using Quarkus, is to target microservices and serverless architectures. That's not to say that if you have a big Java monolith, you can't use Quarkus. You can. We're just saying that you'll reap the largest amount of benefits if you target microservices or serverless. So we want you to embrace the new cloud native world that has taken our industry, let's say, by storm the last few years. And Quarkus was built from the ground up to target these environments. Very briefly, the benefits of Quarkus. First and foremost, when Quarkus was being developed, we had a very important thing in mind. We wanted for people, developers, to be productive. We wanted developers to feel joy when they were using Quarkus. We wanted Quarkus to help you get your job done. We didn't want Quarkus to be a framework that constantly got in your way. You had to fight with the framework to do things. We wanted it to give you a great experience when you're coding and be a very quick experience as well. That means a lot of things. That means like great error messaging. Giving you great error messages when things go wrong, giving you really fast feedback when you code, and we'll see that in the demo. And the second benefit that you've probably heard this title, the supersonic subatomic Java, that we've been talking about. That basically means two things: that Quarkus has a very low memory footprint, and let's say as a result of that, it also starts very, very fast. These two benefits are very important in the cloud native world that we live in, and you'll see that in the demo later on. A third important benefit that unfortunately we won't have time to talk about today is that Quarkus unifies the imperative and reactive programming models. So that means that Quarkus is reactive down to the core, since it's based on Netty and Vertex for all the I/O related operations. But it's up to you as developers to actually decide if you want to expose that reactivity up to your application layer, if you want to use more traditional models like JAX-RS, more traditional blocking models. And finally, Quarkus incorporates and let's say optimizes a lot of libraries that you all and we all use in our daily work to be productive. And to get a picture of that, which library, a subset of the libraries we support, you'll see very, very big names here, stuff that you use all the time. like Vertex, Eclipse Microprofile. You see Hibernate there, Rest Easy, which all enterprise Java applications basically use. And then we have a lot of libraries targeting observability and cloud native frameworks. And of course, you'll see in the middle there's a Spring compatibility layer. And the Spring compatibility layer is the one we'll be talking about more right now. First of all, you might be wondering, like, okay, so why does Quarkus have these Spring APIs, right? So our thinking was, like, as I said in the beginning, we want to we want you to feel joyful when using Quarkus. And what does that mean? That means that you need to feel productive immediately. And for so many Java developers out there, that means that they want to reuse their Spring knowledge. Undoubtedly, like, how many of you are Spring developers? Like, a very large amount. How many of you have, like, never used Spring at all? Okay, 2 people out of the whole room have never used Spring. So that immediately tells you that Spring is very widely used, very widely loved, and for good reason, right? Spring has some very good APIs out there. So we want you to be able to leverage your knowledge. We want you to capitalize on your Spring know-how. We don't want you when you're entering the Quarkus world, we don't want you to have to learn everything from scratch. So what we want you to do, we want you to be able to accelerate your journey into Quarkus by leveraging what you already know. And then once you have spent more time with Quarkus and you're more familiar with it, then you can choose to adopt the more advanced and more, let's say, idiomatic Quarkus features at your own pace. So the idea is to lower the entry bar into Quarkus for people that have, like, spent maybe the majority of their professional career working with Spring. Okay, what do we support from Quarkus? The first and foremost Quarkus Spring APIs that we support is from day one when Quarkus was released, we had Spring dependency injection support. That means the standard dependency injection annotations from Spring, like component, auto-wired, value, things like that. Those worked from day one. Then we added Spring web support for developing REST APIs. So the REST controllers, the request mapping, stuff like that everybody almost in the Spring world uses to develop REST APIs, we provide that. Here's a very brief overview of what that looks like. I'm just putting this slide here so you can understand that there's nothing magical going to happen. You're going to see it in the demo as well. So all you would do, you would add a dependency to your POM XML, which is the Quarkus Spring Web dependency, and then you would write your controller to expose your REST API, just like you would in your normal Spring Boot app, right? So there's nothing different here. You're not going to see any JAX-RS dependencies or anything like that. You're not going to see any CDI annotations. This is just Spring Web things. And let's see how that actually looks like in practice. Okay, so I have my application here. I've pre-generated this application. You can generate it either from the command line tooling we have, Maven tooling, or you could go to code.quarkus.io, and if you select the Spring Web dependency, it automatically generates an application with a Spring controller instead of a JAX-RS resource. And we'll see the POM XML. This is a typical Quarkus POM XML, and the only difference that it has in order to support Spring is that it has this dependency here, the Quarkus Spring Web dependency. So that brings in everything that you need in order to start developing your Spring Web applications on Quarkus. So what I'm going to do now is I'm going to launch what we call the dev mode. The dev mode is what really embodies the developer joy, the developer experience that we want to have in Quarkus. So basically what it is that it launches your application and it listens for changes. So you make changes and then those are instantaneously reflected in the browser. So what I'm going to do here is I've started the application, as you see. Let's go to the browser and I'll go, let's say 8080. And I'll go greeting. So this is a little small. I suppose this is a little better. So that was, I only had one endpoint, and it's the greeting endpoint, and it returns hello. What I'm going to do is I'm going to change that in the IDE. I'm not going to do anything else, just change it in the IDE. I'm going to refresh, and I instantly see my change. So basically what Quarkus is doing here is that it understands what it watches for changes on the file system, and it recompiles everything, reloads everything, but it's so fast, it reloads things so fast that you don't really understand. It doesn't matter to you how it's implemented. And this is like things that are really familiar to like Node.js folks or Ruby folks that used to make fun of us, but now they don't. That's one less weapon for them to use against us. That's all great, but that's just one annotation, right? Let's make this a little better. Request param. I'm going to say request param. I'm going to say default value world. And this is going to be string name. If I could type that correctly, that'd be great. Okay, so hello name. And I'll refresh. And it's hello world because I haven't added a query param. I'll go ahead and do that right now. And I'll say hello devox. So instantly I get my feedback just for making a small change in the code. I immediately see things. Like returning strings is great, right? But it's only good for demos. That doesn't mean anything in the real world. In the real world, all our the majority of our microservices are going to communicate via JSON. So what I'm going to do here is I'm going to introduce a class called greeting, which is going to contain the message that then I'll use to return JSON, just like I would in a normal Spring Boot application using Spring Web. So let's say that here I'll return the greeting, and I'll go new greeting, and I immediately get JSON, right? So just like I would in a normal Spring application, I just return greeting and everything works. This is great, right? But we're all told multiple times in multiple talks and books that in Spring you don't write your business logic, let's say in controllers. You keep these controllers really thin, and you move the business logic to a service. So that's what I'm going to do here. I'm going to move, let's say, our supposed business logic to a service. And I'm going to say greeting. I'm going to create a new one, greeting service. What that's going to do is that it's going to return a greeting. So this is supposed to be a bean service in Spring term, let's say. So that would be this. I'm assuming this is correct in Dutch. Welcome. Is that correct? All right. I know a word. Okay, so greeting service, and then what I do here is that I'll use what the Spring folks have been preaching for a long time, constructor injection. Greeting service, insert. And greeting service dot name. So I think I did pretty good here, right? But actually I didn't. And I didn't because I don't know why, but Quarkus immediately tells me that I immediately get a great error message that's telling me that unsatisfied dependency for greeting service. And why is that? The message tells me immediately that I forgot to make this a bean. So all I need to do here is make this a service, or it could be a component, or whatever else you prefer. And I immediately get my change, right? So I saw the experience is that I immediately get great feedback, whether I've did the happy path or the wrong path. So to conclude this first part of the demo, none of you like hard code values in your code, right? Everybody moves stuff to properties. So what I'll do that now. Private string, final string. Everything should be final. Okay, I'll call this, I'm not going to get creative, so I'll just call it message again. Doesn't matter. And I'll say value, which is what we use in the Spring world, and I'll say greeting message. So I'm using constructor injection here, and because, it's since Spring 4.3, we don't need the at auto wired on if there's a single constructor. So I'll use value. And then I'll also change this here and say message. And I'll go again. And I got another error. And the error message, again, is great. It's on top, so I don't need to dig all the way down to the stack trace to see the message. The message is no config value for greeting message, which makes perfect sense since I never tried to configure it. So what do I do? Like I would do in a normal Spring Boot app, right? I just go to Application Properties, Greeting Message, and I'll say hi. And that's it. So I change my code. I see the changes reflected immediately. I change the properties. I see the changes reflect immediately in like no time. If you actually wanted to look at the output, you could see that hot replace took 0.167 seconds, which is I think almost imperceptible to the human eye. So we're not like the most advanced species biologically when it comes to receiving changes. So this is like very close to the threshold of what we can perceive as a noticeable time. So that concluded the first part sorry, I got to get to the right. Okay, that concluded the first part for the REST APIs. So REST APIs are great, right? We all use them, but what we usually need. We need to go beyond that. We need to expose some data. And the way we usually do that is we have our data in a relational database, and we would interact with it in the Java world since forever with an ORM. And what Spring has done for, I don't know, maybe past 10 years is introduce the Spring Data Framework, which in my opinion is a really great way to interact with relational database and other databases as well. So it gives us a programming model that all we do is create an interface. Spring Data implements that interface for us, makes us very productive from, let's say, we write one interface in very little time, and we immediately can modify and access our data. So what do we support in Quarkus on the Spring Data front so far? We do Spring Data JPA, and we support all the major features, right? So all the features, all the methods you would find in a CRUD repository or a JPA repository, or all the methods you would write by hand on your own, like all your find bys and stuff like that work. Your custom query methods, like if you use @query from Spring Data JPA, we also have that. Repository fragments. I'm not sure if this is super widely used, but I know when I was in my previous jobs, when I was using Spring Data JPA, these fragments that allowed me to compose Spring Data JPA repositories were really great. And of course, transactional support for like updating and deleting data and stuff like that. So what does that look like? Real briefly, because I'm going to demo it as well. You just add Quarkus Spring Data JPA to your POM. Nothing special. You add an entity. In this case, I'm going to use a book. This Spring Data, JPA entity. And with Spring Data JPA, what you would do, and what we'll do here with Quarkus as well, is that you would create an interface called the book repository. And since I'm going to be a little lazy, and I don't want to write the methods on my own, I'm going to use a CRUD repository for the book. And I'm going to add a couple custom methods. The first method will be the find by publication year, because we had like a field called publication year. And then there's an extra method that you supply a custom JPQL query. So this could easily just be taken from any other Spring presentation, right? This is just regular Spring stuff, nothing specific to Quarkus. What we do, though, is we bring that experience, the Spring Data experience, onto Quarkus, leveraging the awesome capabilities that Quarkus already has for interacting with the relational databases. So let's see a demo of how that works. So I still have my application here. My application is still running. So I'm going to use the same one. So what I'm going to do is I'm going to add the dependency that I talked about earlier. Spring Data JPA. That's great. I'm going to tell my IDE to enable auto import, just because I want it to give me autocomplete for the new stuff. And then I'm going to add, since I'm going to use H2 locally, just because it's super easy. You could use any relational database here. I'm going to use JDBC. So I add the dependency for the H2 database. With that out of the way, let's go ahead and actually start coding a little. So book, entity, and like I said, I'll have 3 simple fields. BID is like the book ID, right? So let's do that. Private string name. Okay, and then we'll add one more field. Let's say, yeah, it's the publication year. I'm going to add some getters, and the reason I'm going to add getters is because I'm going to return this from the controller, and the getters make it really easy for Jackson, which is what we use. Well, in this case, we'll use Jackson. You could also use JSONB to serialize and deserialize JSON. What's the next step? Just like in the Spring Boot application with Spring Data JPA, I would create a book repository. Okay, so that's an interface. And like I said earlier, I'm a little lazy, so I'll just extend CRUD repository. I'm not going to use all the CRUD stuff, obviously, but I'm just extending it because the methods are already there and I don't have to write them by hand. The type of the ID was integer. Now, the final coding step that I have to take is to create a book controller. Book controller. So this is going to be a REST controller. Request mapping, I'll say, let's put it under book. And again, constructor injection, private final, book repository. No add inject since there's only one constructor here. And I'm going to do, let's say, iterable of book. And since I'm not going to add too many books for the demo purposes, we can just return them all. So book repository find all. I'm done with the coding part, but I obviously need to add some properties, right? I need to configure where the database is and stuff like that. So just like I would in Spring Boot, I'll use some properties, but I'll use Quarkus specific properties. Obviously, I had them in memory, so I just copied them from the clipboard. I'm not going to write these by hand, obviously. I'm going to use a M2 database, which I'm running as a separate process. The H2 driver, and then the other 2 things that I'm going to do for demo purposes alone is I'm going to drop and create the database schema every time. Since I don't want to be doing that, but obviously you shouldn't be doing this in production. And I'm going to use a feature that Quarkus and Hibernate have where it allows you to import data with a script, so we'll be able to have some data to interact with. So the last step here is for me to add a file called import SQL. And again, I have this in the clipboard. So I'm just inserting 6 books. So now, all I need to do, I need to go back to the browser, and I want to see the result of all of my hard work. And I get it immediately. So let's make that a little smaller. So I don't know if you grasped this here. I'd never stopped the application. I just added a dependency. I started coding. I added all my properties and stuff like that. And I immediately got these results from the database. So I'm not done, because my boss would tell me, yeah, you didn't write anything here. You need to write some stuff that actually returns some business logic, let's say. So I'll go list. I'll say list book. I should import that, otherwise we'll complain. Find by publication year. So here I'm using IntelliJ, the Ultimate Edition, and IntelliJ Ultimate Edition, because it supports Spring Data JPA, you'll see that it automatically auto-completed the method, the name, because it can read the entity. So I'll just use what it auto-completed for me. And the point of this method for me is that what I want to do is that I want to find books that are published between the 2 years that I'm going to supply. Okay, so that was easy. And let's see if I can bring this home by doing list book. And I should have just copied it, but oh well. Publication year. This will be a get mapping again. Now I need to tell it like where it is. So it'll be under year, and it's lower and higher. Yeah, I don't know if this is like the proper, real like the way exactly you're supposed to do it according to the REST manifesto or whatever, but I'm more of a practical person, so this will do for me. Path variable integer lower, path variable integer higher. Okay, return book repository lower and higher, and that looks good. And see, I have all these books. If you see, they're published between 2010 and 2018. So I'm going to go year 2010, 2020. Oops, I made a mistake. But the great thing is that when I have the dev mode, Quarkus will guide me to tell me what the mistake is. So this is a 404, right? So I obviously entered a wrong URL. But because of this great error page, I know that, okay, what I probably meant was /book/year in the two dates. So let's try that. Okay, so these are all the books because 2010, 2020 is all the books. If I go 2017 and let's say 18, I should only see a subset. So I immediately found my books really easily. It just worked. I mean, if I had done things properly from the beginning, it would have just worked without me seeing the error page. Okay, so one last thing. Let's see. Now I've only done get mapping, so yeah, I think it's only fair that we do maybe, I don't know, delete mapping. So I'm going to show another feature here. Let's say I'm going to add an exception, missing book. I'll call it missing book exception. Extends runtime exception. And in a lot of Spring code bases, like you use custom exceptions, and you use the type of exception in order to return a specific HTTP response code. So I'm going to say response status, and I don't know. I'll just choose like bad request when I try to delete something that isn't there. So I'm going to go ahead and add public void delete by ID. Let's say delete mapping. And I'll have to say that it'll take a path variable that's an ID, integer ID. Okay, so book repository, delete by ID. Oh, let's try catch. So whatever exception it will actually throw, I'm gonna throw a new missing book. So I'm doing this just to get the response code that I actually want for when the book is missing. Okay, so now let's see. I'll try to use HTTP to delete this. So delete localhost, all the books, if we saw here, let's go and see them all. All the books are between the IDs are 1 and 6, so if I try to delete 10, let's say, book 10, I got a bad request, which is what I specified on the response status. If I delete the first one, no content, and there it is, the first book was gone. So this is all, this all should be very, very familiar to you. I mean, the programming model here should be very familiar to all Spring people here. What isn't familiar is like how fast I was able to iterate on this, partly because this restarts so fast that I don't even see the restart process. And the other part is that I got great error messages in the browser, not inside a console tucked away under like 100 other exceptions. So that concludes this part of the coding demo. So now let's go ahead and move on to the next part, which is cloud native deployment. So I want to, if I may, raise of hands. How many of you have deployed your Spring applications to like a cloud provider, whether it's using like Kubernetes or not? All right, great. So most of you have done that. How many of you have encountered problems that were related to like how big the application was in terms of memory or how slow it actually started? Okay, great. And there are people that have encountered these problems. And I'm going to tell you a story that happened to me a few years ago of why I started thinking that the traditional approach to applications, the Java frameworks, was actually creating a problem. So let's say this was like 2015, and the whole microservices idea was just taking off, and Spring Boot had just launched and it was getting a lot of traction. And we were tasked in our team to create a new microservice, a new part of a whole bigger application. And since we were really excited about Spring Boot with all the announcement and stuff, it seemed great, and we were Spring Shop anyway. So we decided, okay, this is a great opportunity to try Spring Boot. So we iterated really quickly. I don't know, it took us maybe a couple of weeks to create this new application. And then it was time to bring it into production, right? Because code that doesn't move into production is useless. It's not providing any value. So we obviously had to involve our DevOps folks to do that for us. And the DevOps person that took care of this was also really interested in this new model because he was used to deploying wars on Tomcat and stuff. So we gave him a jar and he's like, all right, great, I'll look at this and I'll see what's different. So he knew his JVM stuff. So he knew how to tune stuff and things like that. So he started profiling the application. And after he started profiling, he came back to us and he's like, no offense, you guys did a good job and everything, but your application uses a ton of memory. And you know why it uses a ton of memory? Because the application has so many classes in it. But we're like, yeah, but we didn't write too many classes. I mean, we might have told our bosses that we did. We wrote a ton of code, but we actually didn't. Like Spring Boot had all the classes there in it for us. And he's like, well, yeah, that's the problem. The framework has so much stuff at runtime, and just running this without you doing much consumes so much memory. So after the initial, let's say, disappointment, it really dawned on me that, you know what, traditional Java stacks really impose a mismatch between developer productivity and cloud economics. What I want to say here is that the things that traditional Java stacks like Spring Boot or Thorntail do in order to make us productive, those same things are the ones that increase the memory usage, and they increase the memory usage a lot in some cases. So why does that happen? Because in order to make us productive in a Java world, all this stuff the framework has to do a lot of dynamic things. That's reflection, creating proxies, doing class path scanning. And when all of this stuff is done at runtime, it leads to a significantly larger footprint. And it's not a footprint that's due to the heap stack that you are using in your application. There are multiple blogs out there, one even from the Spring team that says, you know what, when you launch Spring Boot, the heap size of Spring Boot itself might not be that great, might not be that big, and all the rest is the metaspace. Yeah, but the metaspace which is basically because of a huge amount of classes and a huge amount of reflection and stuff done, is part of the responsibility of the framework. So what Quarkus needed to do and rethink is rethink this model. You know what? We don't want to lower developer productivity in order to get better memory footprint. We wanted to increase developer productivity, but we wanted to significantly reduce the amount of memory that your application uses, and as a result of that, also make it start a lot faster. we all know that in the microservices world, you don't scale up. You don't deploy your application on a larger machine when you need to service more users. What you usually do, which makes more economic sense, is you scale it out. You take the same application and you run it more times. But if your application itself was using a lot of memory, then think about what happens if you have to run that application like 10 times, 20 times, 100 times to service like a Black Friday surge in your traffic, right? And let's not even get into what will happen when you try to move to serverless. Like, let's say your architect is reading all these blogs about serverless and how great and it'll reduce our costs and all that. And you know that with your traditional Java application that'll start in like 5 seconds or maybe 10 seconds, that just serverless just won't make sense, because in serverless you're paying, let's say, per 100 milliseconds of served time. So if your application cold starts in like 5 or 10 seconds, it won't make any sense. So what does Quarkus do different that actually addresses these problems? Quarkus has the main, let's say, idea of moving as much processing that is possible to build time from runtime. The idea here is like there are so many things that are done at runtime with traditional frameworks that don't need to be done at runtime. They can be moved to build time, like things like parsing config files. Like, let's say Hibernate, for example. What's the point of parsing persistence XML at runtime when it's the same file that you actually have at build time? Or what's the point of parsing application properties when you already know that those properties won't change unless you have like an environment variable and stuff like that? Also, stuff like reading classes and doing class path scanning. In a cloud native world, you're not going to have extra classes at runtime. Whatever classes you have when you build things, those are the same classes that you will have when you deploy your application to production. So why do all that work at runtime? And when you move things to build time, like all these opportunities open up. You can, when reflection still makes sense, you can do it up front, some stuff up front. You can create dynamic proxies up front, or like eliminate all this stuff altogether. And you can, in like the dependency injection world, you can wire up all the components that you need, like we saw the services and the controllers and stuff like that. You can wire all these components together at build time instead of doing all this stuff at runtime. So what are the actual benefits of moving all this work to build time? The first and super important is that you minimize your runtime dependencies. What does that mean? Okay, let's say like your framework, like let's say Spring Boot, needs ASM at runtime because it visits classes in order to determine if there are certain annotations on it. Or you have these like maybe even a bytecode enhancer to change class at runtime or whatever. Or Hibernate would need its XML parser at runtime because it would in the traditional world read the persistence XML at runtime. All this stuff doesn't need to be done at runtime, so that means that you can let's say minimize or trim down the dependencies that you actually have in production. That which really brings down the amount of classes you have, which really brings down the memory. The bootstrap classes vanish. What this means is that although the let's say internal classes that your framework has in order to perform all the bootstrapping, like all the, let's say, class path scanning or whatever it did, those no longer exist because all that work was done at build time. And whatever classes, like the framework could have had 1 million classes to do its work at build time, those don't matter at runtime because they're never going to be used, so we don't use them. We eliminate a lot of dynamic behavior. So like I said before, when you have at build time, you know what your classes are. You could like your dynamic proxies are no longer dynamic. It's just a proxy that you have to implement at build time. A lot of reflection, you don't need reflection anymore. You can just use like implement an interface that will call the correct business method. The other thing is that when everything's done at runtime and you scale like let's say 10, 20, 100 times, the startup cost, like the bootstrap cost of the framework, is paid every time you scale up the application. In this case, you only pay it once, and you pay it at build time. And because Quarkus not only optimizes for the runtime, the Quarkus build process is also very fast. So you won't see you'll see a very small penalty when you're building the application itself. You probably won't even think about it. And last, and very important, I'm sure like all of you have heard about GraalVM, right? Show of hands, who's heard of GraalVM? Great. Who's tried to use GraalVM with anything other than Quarkus? 2, 3, like few people. Okay, great. You know how much of a pain that is, right? But because Quarkus does all this stuff at build time, it makes it so much easier to set up the scenes for GraalVM to actually perform its compilation to a native image. What that means is that as part of the build time process, Quarkus can just then use like an extra step with all the generated stuff it already has to tell GraalVM that, you know what, take all these classes. Most of the reflection you don't need, but whatever you do need, we'll provide that to GraalVM automatically. And then GraalVM can then happily create its native image. The other thing is that not only it creates a native image, but it creates an optimized native image, because the more stuff you know at build time, the more hints you can provide to GraalVM to do better dead code elimination. So GraalVM doesn't take, like, you give it a jar and JDK and all that, and it doesn't have all that. It tries to minimize the produced native image. And with Quarkus, with all the extra work that's been done at build time, you can really tell it, you can really give it great hints of what stuff to eliminate. So what is that? What does all this stuff actually like result in at the end of the day, right? So at the end of the day, let's say you have a Kubernetes cluster with a Kubernetes node. If you in your traditional Java enterprise Java world with Spring Boot or Thorntail or anything else you can think of, in one node you could pack a certain amount of instances of the application, right? So whether it was a jar, a war, whatever, you could pack a certain instance. With Quarkus, though, the end result is that you can pack so many more instances into the same node. And that's because it takes so much less memory. So you can, for the same hardware that you have, you can serve so many more requests. And now I'm going to do a demo that's where I'm going to take an application. Let's see, I'll call it the side-by-side demo that I stole from some great colleagues at Red Hat. And what it is it's the same version of a very simple application. It's called, like, let's say, the greeting service or whatever. So it's a Spring Boot app here that just returns JSON. And in its POM, I'm using, what am I using? I think I'm using Webflux. I'm using the actuator. And this has been already deployed to Kubernetes, well, to OpenShift. I'll show you the console. OpenShift is Red Hat's enterprise version of Kubernetes, but you can think of it as just Kubernetes. I've already deployed that there. Then the other version, I have the same application, well, the same greeting controller. This is a Quarkus application, though, because I'll see here I'm using Spring Web, and I'm using the built-in health checks, because when you're deploying to Kubernetes, you need to have your health checks, your readiness and liveness probes anyway. And for comparison, I'm also going to have a Node.js application. This Node.js application I wrote in Happy.js, which is a very known Node.js framework. And I'm adding Node.js because a lot of people use, like, when they're moving to microservices, they think that they choose Node.js because it starts faster and it uses less memory than the JVM. So what I'm going to do now is that here I've already deployed, this is the console, the OpenShift console, which is just Kubernetes, but in this case I'm using OpenShift because the UI is way better. So we can see that I've already deployed the application. It's the same version of the application. I've deployed it onto Kubernetes, and there's only one node running now. But what I'm going to do is I'm going to simulate a traffic spike. So I'm going to send a large amount of traffic to each one of these, and I'm going to see how fast Kubernetes, and in this case, utilizing Knative, can scale up this application. We'll see that. What we'll hopefully see, if, like, the internet connection works and everything, is that the Quarkus application will scale a lot faster because it can start up so much faster, and it'll consume a lot less memory. So in the other tab here, I only have, like I said, I have one version of each running, and these are serving a very low amount of requests, like I'm sending one request per second here. And what I see is that with these numbers, The Spring Boot application will take now it's at 160 megabyte. The Node.js application is 112. The Quarkus application, which I remind you is the same, let's say, business logic as the Spring Boot application, is taking the least amount of memory of all, even less than Node.js. So in this case, I've taken this application, I've converted it to GraalVM, to native image utilizing GraalVM. So let's move on to the other. Okay, here what I have is I have a script that basically on the top, what I'm seeing is I'm counting how many pods are ready. On the top left, I have Spring Boot. So you could hopefully see the title. It says Spring Boot Ready Pods, and then Node.js Ready Pods, and Quarkus Ready Pods. And on the bottom, I just have a script that simulates increased HTTP load. So what I'm going to do, I'm going to start with Spring Boot, then I'm going to move to Node.js, then Quarkus, and which means that Quarkus is at a disadvantage here because it will be the last one to receive traffic. But what I am most likely going to see here is this will take a few. Okay, so this cluster is also really slow. It runs on a public cloud on very low-end machines. So this won't scale as quickly as you would on better machines, but you immediately see the results, right? So the Quarkus apps are scaling immediately. And Node.js hasn't even started scaling, which immediately shows you the power of all the work that has been done in Quarkus. Like in this is like Knative, so it's sort of serverless. And immediately, based on traffic, you see how much faster Quarkus has started. The Node.js counts are coming up, and the Spring Boot stuff, the vanilla Spring Boot stuff, hasn't even started. And it's not started not for lack of trying, right? The cluster has started to provision these pods, but as you can see in the readiness probe, they're not ready yet. And they're not ready because they take a very long time to start up. So if I move to the other tab here, as these are coming up, this console shows me the top 10 memory consumers. And if you see here, you'll see one Quarkus one down at the bottom. All the other ones are either Node.js or most of them are vanilla Spring Boot. So that immediately shows you on a cloud environment how important it is to consume a lot less memory and to start up a lot faster. Okay, so let's recap real quickly. What we saw here is that how you can leverage, as a coder, how you can leverage your Spring knowledge to build applications on Quarkus utilizing Spring APIs. We hopefully show how much what the benefit is of using Quarkus to increase your productivity by seeing your changes immediately, and how much sense it makes to use Quarkus applications in a cloud-native world. And you can therefore embrace this cloud-native world as a Java developer without having to compromise, without having to worry about how much money, let's say, you'll pay to your cloud provider. Because I'm sure most of you would rather not pay than have to be stuck with a substantial bill. So I think we have a couple minutes for questions. I'm just going to leave these here. I have a bunch of links for the Quarkus stuff. Quarkus guides these slides, and then all my code that I demoed here is also on GitHub, so you can find all the stuff here. So we have, I guess, a couple minutes for questions. Yeah.
What other Spring integrations do you have now, or do you have planned in the next year?
Okay, so the question is, what more Spring integrations do we have now, or do we have planned? Okay, what we have, this is an ongoing, let's say, process, right? So we're trying to get more feedback from the community to see what the community actually wants. But what we do have now is we have a Spring security in progress. So that will probably be the next one that will be implemented. And we have a lot of thoughts, maybe around Spring Cloud, and some folks have been talking about maybe Spring integration or Spring Batch, things like that. But it'll really be decided, I think, by what the people, what the community actually thinks is the best fit for this. Yeah. Yes, Kotlin is support. Sorry, the question was if we support Kotlin. Yes, Kotlin is supported in Quarkus, and you can use it with Spring stuff or non-Spring stuff, and it'll work. And it'll work in native as well, right? Oh, I just remembered that I forgot to show you how fast the initial application with Spring Data JPA starts. So when we compile it with native, which would be just like add a native flag, an MVN clean package native, which I can do really quickly here. Okay, I'll stop it, and then I'll go package MVN clean package dnative. That's all I would. Dnative is all I would need to make this into a GraalVM. I'm not going to do that because I'll have like 0 time. So I've already created it here. I'll start it up, and it will start in. It started in 11 milliseconds. So this is a Spring Boot app with Spring Web and Spring Data JPA, and it started in 11 milliseconds. And let's make sure that it actually does work. I assume you like that, right? That's like the startup time, and there it is at work. 11 milliseconds. I think that's a good way to end the talk. So thank you very much. Thanks for attending.